Hey, good afternoon, everybody. Today, what I decided to do is actually go through a couple of these problems that are going to be part of your assignment, and hopefully, maybe we can clear a few things up with what we have going on as far as 8-3. So let's just go ahead and dive into it. All right, and what I'll do is I'll do an example of number one. Whoops. I'll take care of number one here and also number three. And then what we'll do is you'll just apply what you did with number one to number two, and then also what we do with number three, you can do the exact same for four, five, and six. All right, so with number one, what we're looking at here, it's saying to identify the asymptotes. Now, when they're talking about asymptotes, they're really just talking about x and y. Okay, and so like we were doing in the past sections, we were solving these compound fractions. Now with these, we're just going to be locating 2 points, x and y, and then we just fill out our data based off of that. So the way we get x is by looking at that denominator. And you can see here the denominator is x minus 1. So what we need to do is say x minus 1 equals 0. All right, and now the only thing we're going to solve here is this statement right here. And we do that by just moving -1 to the other side, and we end up with x equals a positive 1. Okay, so I got x as x equals 1. All right, now if you notice on these fractions, some of them have a whole number at the end. Like if you notice here, number 3 has a -3, number 4 has a -6. Number 5 has a positive 3, and number 6 has a -2. That's, in the sense, that's your y-intercept or your y-coordinate. So the number 1 doesn't have that here. So when there's something not there, we just assign a 0 to it. Sorry about my handwriting. I'm trying to write this with the tablet sitting up so you can see, so I can record this. So our asymptotes are x equals 1 and y equals 0. Now, to get the domain and range, we just state the opposite of x and the opposite of y. So the domain for number 1 is going to be x cannot equal 1, and y cannot equal 0. That is our domain and range. That's different than the asymptotes. All right, so from this data, our answer box is going to be this right here. The really only problem solving that we have to do for this part is the working with the denominator of that fraction. All right, and that's all you'll need to do for number 2. All right, so with number 2, just a little hint: if x equals 0, then x just equals 0, because we don't have any problem solving like we had to do over here with that. So we'll just say x equals 0. So that's kind of your starting point for number 2, and I'll write that on there. X equals 0. Close that in a little bit. There we go. All right, let's dive into number 3. Now the tricky part is these graphs can be a little misleading. Just remember, and I'll do the work for number 3. Number 3, we always start with that master graph. And with that master graph, it always looks like this. Try and get some nice straight lines. I'm just going to plot a graph right here. Okay, and our master graph is just simply at the origin of 0, 0. All right, and then we have our graph lines that curve in this and this. Okay, we always start with that at the beginning. That's always our starting point at 0, 0, with our curves right here and right here. Now, what we're going to do is we're going to take a few things from this equation, and we're going to change the master graph. Okay, so the first thing I need to do is the same thing we did in number 1, and that's identify my x and my y. All right, so let's go ahead and do that. So with number 3, I have to look at the x plus 3 equals 0. And I just solve for x, and I get x equals -3. So there's my first part, okay? So my new graph, which I'll label over here, new graph. And let me build it real fast. Okay. My new graph, I'm going to take and move 0, 0. Okay, so 0, 0 is going to turn into the data that I get from number 3. So I already have my x. Now to get my y, I look at this right here. And that means y equals -3. So my new graph is now going to be called -3, -3. So from the origin, which is the middle right here, I'm going to go and plot the point -3, -3, which is done like so. All right, so there's -3, -3 at that point right there. All right, and then we're going to put our new graph, and I'm going to change colors here so you can see this to blue, and I'm going to go down first for my y-axis, and then I need to plot my x-axis. Okay. Now from here, I just need to state the domain and range, and we can just simply say that x cannot equal. So for domain, x cannot equal -3, and the range, y cannot equal -3. Okay, so what we did was we plotted our new origin. As you can see, it moved from 0, 0 down here to -3, -3. Now the last thing we need to do is we need to put our curves back in it also. So to put the curves, I'm going to do that in red. And when we do the curves, we want to look at what A is, okay? And A is the numerator. Okay, and I'm going to need to know if I reflect this or not because there were some rules in your note packet. All right, and with this it says A is going to be a 1. So A equals 1. Okay, so when A equals 1, I'm going to simply just put the lines back where they go. All right, so I'm just going to copy exactly what happened here, and I put a curve here and a curve here. Okay. Now I put some notes out on your assignment to see what happens when A is less than 1, and there's an example on there, and they actually flip-flop across the x-axis. So what happens is this moves up top and this moves down here. So for example, you can see number 4, A is going to be less than 1. So you're actually going to reflect those curves when you're done along the x-axis. Okay? So for that being said, that is what we need to do for 4, 5, and 6. You're going to tell me what x and y is, the domain and range. That way you'll be able to write your new graph and put curves on it. Again, if you have any questions, please feel free to email me or message me, and I can do another example for you. All right, thank you and good luck.